My name's Matt Endsley. I'm the CTO and co-founder of Carbon Games. We're a local game studio here in Bellevue. We do a free-to-play game called Airmech. It's an action RTS game that's mainly on PC and consoles right now. And I'm going to talk a little bit about how we went about starting Carbon and over the last 4 years or so, growing our game and building a company from scratch without taking any significant investment from the outside. So when we started Carbon, the big thing to do is when you're starting a company is actually figure out what your goals are. It's very easy to kind of go in with like, I want to build a project, but I'm not sure how the company itself is going to run. And I think that's a big mistake. So we sat down when we started Carbon about 4 years ago to define what our goals as a company were going to be. And the main thing is we wanted to build the games that we wanted without giving up a lot of creative control. We'd done startups in the past where we'd been part of a strategy that's basically like you have some big exit strategy where you go to an IPO or you're getting acquired, and we kind of wanted to avoid that. And we wanted to be able to focus on our project itself rather than on this external investor pressure. And the other thing we wanted to do is as part of that is be like a long-term company. We want this to be like the last company that we're working for. So we want to be like get to a point where we can have a sustainable salary and kind of have this long 10, 15-year company. And we do that by making Airmech. So it's basically a giant transformer robot game where you fly around and blow stuff up. And the key goals with Airmech was we want to make it fun, and because we're bootstrapping the company and we've got a very limited amount of financing that we're working with initially, it's get to what we called revenue allowed as fast as possible. So we want to build this minimum viable game and get it out to market and have people generating money for us as quickly as possible. And so our schedule of Airmech was really compressed. So we started the company in June 2011, and we basically were putting together this prototype of something we'd been working on for the last few months, and we showed it within the first 30 days at the Seattle Indies Expo that's run down by the 17-bit guys now in Seattle. And at the time, we didn't even have a name for the project. We just basically showed up with 2 monitors and set up a game and let people play it and kind of get a feeling for where we wanted to go as a company. In August, we showed it at PAX Prime for the first time, and we just basically fell into some booth space last minute. We had a friend studio of ours had to pull out. They lost their funding and weren't going to be showing, and we basically took over this 6-foot table in the corner of PAX, and we crammed 4 monitors, 4 PCs onto it just to get the exposure for the larger audience there. And right after PAX, we immediately went into like actually launching this game, and not in a traditional launch sense, but putting it out there so that people could actually get it and play it. In September, we added multiplayer support so that you could actually, which is really key for a free-to-play game, is having people being able to play with their friends, engage with their friends. So we went from PAX showing a single-player game to having a multiplayer game within the next month, and then 2 months later, we had our first actual like hosted environment. So we spun up servers out on the cloud and had multiplayer games, and this is when we started giving the game out to people like via our website. So it's really minimum exposure, but all the key things were in place at that point. So you integrate billing. We're going through like PayPal and Amazon and Google Wallet at the time, and you just get the product out there and a way for people to pay you. That's really key to. I think a lot of people forget like how people are going to actually pay you, and that's one thing that we focused on really early on. And then from that, we went into a pretty aggressive launch schedule on a few platforms. So we did Google's native client in early 2012. It's basically a platform for running a native regular PC game inside the Chrome browser. And then following that, we launched in Steam. I guess it's early access. They didn't have early access when we launched on Steam in the summer, spring of 2012. And then we went quickly into, we grew the game on Steam and started looking around for partners that could help us bring the game to console platforms. One of the big things is we didn't spend a lot of money on user acquisition on PC, and we tried to keep the game small. And so like the game is still branded as beta on PC, and you'd be surprised by how much leeway that gets you. If you very prominently display a little logo that says beta, people will give you a lot of slack for things that aren't polished and aren't finished. We'll even get players in game someone will complain about something and the other players will evangelize for us. Like, settle down, it's just beta, they'll fix it later. And if we could stay in beta forever, we would stay in beta forever. So we should look for partners for consoles. We went with Ubisoft, and it's a lot easier getting a publisher deal when you have a built established product. There's a lot less risk on the publisher side, and you can negotiate a lot better terms. And so we did Ubisoft, and we released on Xbox 360 in summer fall 2014, and we just released this week on Xbox One and PS4. And then going forward, we're pivoting the company a bit after the console launch and focusing a lot on VR. So we're building like a tabletop experience of this RTS for VR. And I think we're really excited about the prospects of VR, and so that's kind of where we're going in the short term. So going into the technical aspects of building a free-to-play game, like one of the biggest concerns is where's all this account data going to live? And I see a lot of companies, like, they spend a lot of time stressing about, like, what database am I going to use? I need to build all these clusters. And like, my advice for that is you don't need a database. Like, it was one of our biggest decisions. So we came from building MMOs. So prior to Carbon, we built MMO technology in China and East Asia. And we have lots of horror stories of these giant SQL installations or these giant MySQL shards, and you can spend a lot of engineering and planning effort trying to build out these technology solutions that you just frankly don't need when you're starting a company. And so, like, the caveat here is you don't need a database yet. You will at some point, but when you're starting out, that shouldn't be your big technical focus. And so what we did is we used the file system as our database. We stored all player records as individual files on a server. We minimized relational data. So it's surprising, but you'll find that a lot of gameplay data on your servers isn't really relational. There's not a lot of times where you're saying, let me find the amount of money that this guy spent and join it with the amount of money this other guy spent. A lot of data is just very central to a single user and doesn't need to be queried across multiple users. And so this process worked for us to about 800,000 accounts. And we have a folder with the username on it, and inside's a handful of JSON files. There's a file for, like, account info. There's a file for their inventory, a file for how much currency they've spent in the game. And our biggest limitation is we didn't run out of file disk, and we didn't run into I/O limits. We actually ran into inode limits on ext4. So when you allocate a file, there's a fixed resource per file that's allocated to address these files, and that's what we're running into. And that kind of prompted our migration to a more traditional database solution. The pros of doing this is that the file system is really fast. If you're writing to attach storage on a server, you're not going to beat that for persistence. It's really fast, and it's really easy to use and maintain. There's a lot to be said about being able to troubleshoot account issues by just opening up a file in Notepad and fixing something directly, rather than having to find someone who has a lot of expertise in a database to figure out what query to run and what process to run and mess up all of your data. The cons is that it's a single point of failure. So when you're writing to attach storage on a single server, it's all of your account data is living on one machine. If that machine dies or you have a hard drive crash, like, everything is gone. So that's a big thing. And then we ran into some weird concurrent issues with accessing account data. So you have to be very careful that you're not having two separate threads on the same process writing to the same data. And for this solution, it seems strange, but we had a single mutex in a single process. So our servers are written in Go, so it's a very highly concurrent language. And there was one mutex that was held when writing any piece of data anywhere, and that actually scaled to the point before we started doing consoles. So it was up to about 4,000 concurrent users or so. We had just one lock that we'd hold anytime you're writing any piece of data. And then we had write swap recovery issues. So another thing is when you're writing files out to the local file system, you don't want to be touching, like, your authoritative file. So say you have a wallet file that has all the currency that the user has in the game. You don't want to be writing that file directly. You want to write to a temporary file and then atomically move it on top of the other file. That way you don't end up with things like half-baked files that can't parse and things like that. It runs into other problems of, like, how do you handle crash and recovery? What happens when you have a partially written file and your old file? And so one of the systems we built is we build these kind of like transaction logs into the system where you can roll back like an entire account to a specific point in time, and that helped us alleviate that issue a lot. And so with this file system, like our initial cluster overview, so if you think back to that slide when we were launching our servers in 2011, September 2011, this is our entire cluster. There was a single Linux machine that was sitting in my living room running off of Comcast internet that was running everything. All the account data, all the login servers, the game servers was running on a physical box in my living room. And there was a point where I had moved apartments in Seattle, and we had scheduled downtime for like 3 hours as I like picked this box up, physically drove it to my new apartment and plugged it in. And the entire AirMech game was offline for this 3 hours while I shuffled this around. And it's something that you can afford to do when you only have like 1,000 users. You can bring everything down and move it. And so we hit that 800,000 limit or so, and that's when we started running into, so we ran into inode issues, and we started running into CPU issues for having one machine decode all this traffic for the accounts. And the main driver was to be able to have multiple servers being able to access account data, and that's the main drive for moving to a traditional database system. We experimented with a few things. We experimented with MySQL, we experimented with MongoDB, but ultimately settled on Couchbase, which is basically a glorified key value store. It doesn't have a lot of query functionality built into it. It kind of has this overarching JavaScript map reduce operation, but if you're used to being able to arbitrarily select across a table, this won't handle that type of query operation. But as I said, like our data wasn't very relational, so the types of queries that we're running were fairly limited to begin with. And so Couchbase was chosen because it's easily scalable. Every single process is identical, so you can just add a new node to the cluster, and it auto rebalances, and it can figure all this stuff out for you. And our migration process was pretty straightforward. So we started with these flat files on the system, so you'd have like an info.json underneath my user folder. And that just became, the path itself became a key. So we have like user ID, :info, and would just point to this big JSON object. And the big advantage here is that the data is now accessible across the shard. So you have the ability to start adding more machines to spread out the workload more. I guess you also have the benefit that you're no longer worrying about your central point of failure. You can lose this one machine and not lose all of your data. So our cluster overview kind of migrated from, so our migration process, we started with this entire shard to having a Couchbase cluster. And so this was 3 separate server nodes sitting off to the side, and everything was running basically the same as before. So the shard's the same, but instead of the data being stored locally, it's stored in this data center, or this Couchbase cluster within the data center. And the next move that we made is we offloaded terminating SSL, which was accounting for about 40% of our CPU usage, was decrypting SSL traffic from the clients. It was something that we didn't expect or predict, but the Go runtime was really bad at doing this, and we offloaded this to it's a project called Stud that just basically unwraps an SSL TCP connection and writes out raw TCP on the other side. So we built a few nodes that could unwrap this traffic and then basically funnel it all down into the login server. And then once we had this set up, we just started slowly moving client and player logic off of this main single point of failure server onto these front end servers. And so today we have an array of these front end servers that sit in front of the login server that do the bulk of player and account logic. And the login server, for the most part, is just doing matchmaking work now. So it's in charge of wrangling gameplay servers and matching players to each other. One thing that we found a database is not good for, it's really good for storing like an instant snapshot of what everything looks like at time, but a lot of support issues that you'll get have more to do with the history of an account, like how has this account changed over time. And we found that the best way to kind of store this progression of account data is using human readable logs. So we just have every process is writing to just a text file, and we log everything, like things that you wouldn't think that you need to log. It's just don't be terse with your log files. Write everything out, because you never know when someone's going to email you and you're going to have some weird scammer guy that like logged into somebody's account because they used a disposable email and transferred all their items off of it, and you have to go sort out what happened. And so we write all these giant text files, and then we use just really, really basic data mining tools. We'll talk about it in a minute, but basically grep and awk are your friends. You can just do almost anything you need to with those. The advantage is that they're small, they're easy to parse, and yeah, having something easy that you don't need a lot of technical knowledge for support is pretty invaluable. So our servers, we run everything on really small Linux VMs. Most of our servers are 2 gigabytes of memory, and we use the bulk of everything's through Linode. They provide pretty good worldwide coverage. We do a handful of other hosting options to get coverage in like South America or Australia, which are notoriously hard for online games. Like I said before, all of our servers are written in Go, which is a language by Google. It's just very C-like, but highly concurrent. And then we expose to the client, we expose an HTTP-like interface. So a lot of the stuff uses HTTP requests, but it's kind of multiplexed onto a regular TCP stream. So we're not building up and tearing down connections all the time. And we kind of interleave some real-time data in there. So multiplayer chat and global chat in the game kind of flows through this same stream. But the bulk of the data and the operations are used with normal HTTP request response semantics. And one of the big things that we focused on when building these servers is what we call crash-first development. It's if you ever asked what the proper way to shut down a server is, it's just to kill it. You go and you Control-C the process, and it is amazingly useful to be able to deploy new server versions by just pushing a binary and killing the old process and having the new process start up without dropping users. And so this requires a bit of engineering work to make sure that your clients can gracefully reconnect when they've dropped connections, but the ability to have fast turnaround time on deployment without downtime is pretty substantial. So one of the other aspects when this is for us was specific to building a free-to-play game was having some real-time stats. This is we have an admin console web page that basically shows these updating charts and graphs of what is going on the game right now. And the main question to answer is that at any given moment, someone can look at this and get an overview of like, is anything broken? Is anything significantly on fire right now? And you can build real-time alerts that can email you and message you, but there's something to be said for looking at a graph that shows like sign-up activity over the last few hours, and you see something weird in the graph that you don't have an alert rule for, and you can kind of tell that something's up. Like maybe the New Jersey data center is down all of a sudden, and that's affecting sign-up growth. So the big metrics that we track with real-time stats are our concurrent users, our unique users, our current total signups over a 24-hour period, and like I said, a lot of these derivative stats are really important. Like what's the rate of signups over this 24-hour period? Is the rate increasing or decreasing? And you usually find that these rates follow like your standard concurrent curve for the day. You'll have your peak times and your off times. We track game completions and game completion rates. How fast are people getting into games? What's the latency that they're experiencing? What's the average frame rate that they're running at? And then of course things like revenue, tracking how much money's coming in. So it's also important to keep these real-time stats in a format that's easily consumable by your admin tools. Well, these are separate, so we'll talk a little bit later about building stats that are like actually important for publishers and long-term corporate growth. So this is more about real-time instant access to get an overview of your server. So ours, we sample data every 5 minutes, so we're accumulating statistics on our server, and every 5 minutes we go through and we dump out the current values of all of our counters to a giant JSON file. And so there's a daily file that rolls over that basically is an accumulation of all these counters. And then the admin web page just basically pulls down this JSON file and parses it all. Another thing that we found is that if you're willing to lose data historically, if you're willing to put stuff into RRD tool is really great. It's a round-robin database. It basically is a fixed size database that you can put data into, and it has automatic aggregation. So you can have, I want to sample data once every 5 minutes for a 24-hour period, and then it can automatically aggregate into weekly and monthly and yearly stats and build out graphs for you. You just start losing resolution in that data. So backups are really important. Everyone thinks that, but no one actually realizes it until you have to go through some sort of disaster recovery mechanism. And I can't stress this enough, is that you are going to lose critical data, and you're going to lose it at the worst time. There's no way around that. In the last 4 years, we've had four hard drives physically fail in our office that were hosting things from just like a local file share to actually our server that does on-site backups for us lost hard drives as well. So hard drives are going to fail, and you need to plan for this. We've also had 2 production servers that are what I call fat fingered. Someone hit the wrong button, and we had a server get completely deleted and rebuilt from scratch on the server. So we lose the entire hard drive on the server. It's like, these are things that will happen, and you have to actively plan for them, or you're going to be sitting there trying to explain how you've lost a third of all the account data. So daily backups, they'll save you like 95% of the time. If you take a snapshot of everything that's happening and you just archive that off somewhere, you'll be covered for almost all of your cases. And then, so what we do is we do daily backups of our Couchbase shard, daily backups of all of our other shards. And then on top of that, we do hourly backups of that giant text file log that we're talking about. And that covers basically the remainder 5% the 12 hours that have elapsed since your last Couchbase backup or whatever. People are going to buy stuff, they're going to spend money, and then that data is going to be lost, and you need some way to quickly recover the state of how everything was. And aside from some magical solution that just instantly replicates everything at the speed of light to some other data center, you're going to have some plan for manually going in and fixing this data up. From a technical side, we use rsync for pulling down all of our log data. It's just a pretty straightforward tool that syncs these log folders across. And we use LLVM on our database machines. LLVM is a file system or not LLVM, I put that in the slide wrong, just LVM. It's a logical volume manager for Linux, but basically allows you to do instantaneous snapshots that don't really take up, it's a copy on write snapshot, so you can have a volume without taking up significant extra storage space that you can then mount in a read-only mode and pull down. So you can take your database and without shutting it down, create a snapshot of the file system as it exists right then, pull that image down without having to stop and start your database. So yeah, for backups, yeah, if you're using something else than Couchbase, so Couchbase has built into it that it guarantees that the file system's in a stable state at some point. Some other databases don't do that, where the file system could be in some intermediate state, the actual backing storage. In that case, you want to use like whatever your native backup tools are. So like MySQL dump, for example, for anyone who's administered MySQL servers. We actually use LVM. So Couchbase does come with a native backup tool called CDB Backup, but we found that running it actually degrades the performance of our running shard to the point that our Couchbase cluster becomes unstable and starts shutting down and running in replicated read-only mode. We're not really sure why this happens, but we know that's why we switched to LVM. Yeah, text data. If you use rsync, I would highly recommend looking into the hard links option. It basically lets you say, if you have a snapshot folder, you can use rsync to create a copy of that snapshot folder locally using hard links in Linux, which save you file space. It's basically a pointer to the original file that changes only when you write the file and update it. And then you can rsync on top of hard links, and it saves you a lot of time of having to pull down data that you've already copied from the server without using a bunch of hard drive space. And then once you have all this data backed up, so we do an on-site and off-site backup. And we use our on-site backup to do all of our data mining. And this is where you're looking for bigger trends in your games. And we do this we automate this process basically using some really simple bash scripts. So we use bash plus a cron job that basically runs awk and grep and sed over all these log files that we're generating to kind of build a historical record of what's happening. And we export this into a CSV format, and that just basically is copy pasted into a giant Google Doc. And so what we do for our key metrics is, so these are things that, like, if you're going to a publisher, these are the values they're going to ask you for. And we aggregate this into weekly and monthly charts. And so, like, these values that we use, they're uniques. They're how many unique users do you have coming into your system? How many unique users do you have coming in a week or a month? What is your sign-up trend? What's your active user trend? These are like retention numbers. So we calculate 1 day, 3 day, 7 day, and 28 day retentions. And we do the 28 day instead of like a 30 day or 31 day because we want to, there's a big difference between signups on like a Thursday or Friday versus like a Tuesday or a Monday. And these tend to keep the data more normalized. Is that you're tracking if a player signed up on Friday, what's the chance he's going to come back on the next Friday? And then you're tracking like your revenue per user. This is your total revenue in over how many unique active users you have, and then revenue per paying user, which isn't really as important, but it's a good metric to see how much value you're extracting out of individual users once they've crossed over the conversion barrier. Most publishers are going to be more concerned about revenue per user overall, because that's an easier thing to project and to predict for growth of the game. Revenue per paying user is more of a metric of how well are you converting non-paying users to paying users. How well is your promotion in game? How well is your promotion for buying things? One of the things we found is that our unique users to our peak concurrent users is pretty constant. We sit at about an 11x multiple. So like our peak concurrent users for the day will always be about an 11th of total unique users. And that's scaled with our game from 200 peak concurrent users to 12,000, 20,000 peak concurrent users. We found that this is a pretty constant multiple, and it's a good thing for finding out whether something's going wrong with either your marketing or anything like that, is whether this number changes. And so I don't know if we have time for questions or if we're running close.
We have time for one quick question.
Well, maybe I'll ask a question then.
Right.
You talk about your SS acceleration. Is that hardware or software solution?
It's a software solution. So we're running basically on VMs in the cloud, and so it's it's all software. Okay. So we're using basically an SSL reverse proxy called Stud that's basically running through OpenSSL.
Have you looked at hardware solutions?
We have not. So one of our big things is we try to run really lightweight on our server infrastructure. So getting a hardware solution likely involves us switching hosting providers, and that's a big pain point for us, is moving everything to a new hosting provider. So like getting something like an F5 switch that can do all of this in hardware for us. It's just something we haven't gotten to a point where it's been a big enough performance issue to look into in depth.
Okay, well, thank you very much. Are you going to stay around for the rest of the conference?
I will, yes, I'll be around.
Okay, well, thank you very much.